Howdy everybody in YouTube land. Welcome to part 2 of our IntelliStar restoration repair series. This might sound a little different because I went back to my other phone for my camera. So, in this phone I retired a long time ago because, well, I got mad at it, and yeah, anyways, that's a story for another time. So, the components have finally come in from the slow boat of China. It only took a couple of weeks, but now we have them. And I bought 2 new ones. These are not part of it. These go to a PMX unit, which will be in a different video coming up. But so I bought these, which are these 2 chips here, and they're connected directly to the front end. So this is first in line when they get damaged from a lightning strike. And then this is the chip that goes here, and that's what I need. So I got used ones, and I got some brand new ones. These are still in the tape and reel package, so that should be good there. And then this one are these here, but they're kind of wrapped up into that same frame thing. So I'm likely going to move it from these into these little boxes here because I trust those more than those. I don't want them, falling out. But anyways, so we're going to go ahead and get set up in the stands here, and we're going to go and start this video off by putting the new chip on this card. Then we got to work on the power supply, and once we work on the power supply, we're going to get the thing put together and test everything, and that should conclude this video. But without further ado, let's get you set up in the stands, and then we're going to start getting everything prepped to work on this card. And hopefully that this chip will fix the lightning damage that happened to this one where we had no output in the previous video. So if you remember, we had input coming in, which is here. We had input coming in and everything would show fine on the monitor, but we had no output going from the composite to NTSC. So this chip is responsible for that, and we're going to go ahead and replace that, and let's cross our fingers and hope that this card is going to work again. And before we do that, we got to clean off the flux and all that. So we'll get to that, but let's get you set up in the stands. Everything should be good. Alrighty then. Now we have the card out, and as you can tell, we have to replace this chip right here. So what we're going to do next is get the soldering iron warmed up and all that ready to go. But I want to get this old flux off, and the only way we're going to be able to do that is to use a little bit of flux cleaner, which I've had this stuff for, I don't know, I want to say 2008. It's been a while. So, alright, let's get this guy cleaned off. And if you don't want to see this process, feel free to skip on by and look at the finished result. Alright, all clean. No more flux anymore. Alright, so get that out of the way. Alright, so what I want to do next is inspect the solder joints, make sure there's enough solder there to retain the new chip, and it looks like there is. So, as with our previous video before, we grab the flux. What I want to do is lay a bead out around all 4 sets of, all 4 sets of pins here. So I'm just going to lay out a bead here, here, there, there. Alright, now we have some fresh flux on the pads, and then the other thing we got to pay attention to when we mount this chip is there's a white dot here. That white dot indicates pin 1. So we need to make sure that we position the chip in the appropriate spot. Otherwise, things are going to go very badly, very quickly. Especially when you power it up. Alright, now we need our little suction-y tool. Actually, we need our mount. Not to melt the plastic this time. So, alright, that's all positioned where you can kind of see how we're going to do this. Alright, now I need to chippity doodah tool. There's a correct term for that, but that's what I'm calling it. Chippity doodah tool. Alright, pin 1. We got to figure out where pin 1 indicator is on these guys here. And typically they are right there. There's a little circle embedded into the epoxy that indicate where pin 1 is. So what we're going to do is I'm going to position this tray exactly to where we need, and then I'm going to grab a chip here, and then we're going to drop it into place just like that. Nothing crazy, nothing fancy, just get it in position. Put that up since we don't need that anymore. The other thing I want to do is I want to grab my tool here, and then we're going to try to line this up the best we possibly can to make sure that the solder is going to flow correctly, because the last thing we want to do is flow them onto the wrong pads, because that would also not be a good thing. Alright, that's in place. So next step in the whole process is turn the heat gun on and let it warm up slowly but surely. Remember, with this kind of thing, take your time. Do not rush this. You'll know when you're ready because the solder will turn shiny and you'll see it flow up onto the pins. Smell that flux. And again, just like last time, be careful not to cook the crap out of the capacitors, because that would be a very, very bad idea. Oh, I can see them go shiny. Starting to see the solder flow. And that should do it. Turn it off. Let it cool down naturally. Now the only reason why this works is a little bit of the solder was left behind from when we removed the old chip. So once you remove the old chip, it's going to leave some of the solder behind. So there will be a little bit less solder on here than there was before. So the next thing we need to do is, after we do this, is we need to actually inspect the solder joints and make sure that they all took. And if they didn't, you'll have to touch them up with the iron. The best way to do this would be to clean all the solder off, grab a stencil, solder paste stencil, and lay down some solder paste. But when it comes to doing a quick rework of a board, I don't think that's all necessary. So the next thing I want to do is just inspect all of these, make sure they've flown into place, which it looks like they did, but it's really hard to tell because there's only so much solder. Yeah, some of these I don't think have enough solder on them, so I don't think there's enough solder left on the pads, so I don't think that took properly. Let's see. So I'll tell you what we're going to do next. Just to ensure that there's a good strong bond between this and the board, I'm going to grab my flux. I'm going to reflux it. I'm going to reflux the board with a little bit of, just nothing crazy, just a little bit here. Let it melt into, because the board's still warm. You let it melt into the pins here. Just kind of give it a good douche. Don't go overboard unless you're going to ultrasonically clean the board, which I'm not going to do that in this case because my ultrasonic cleaner is at work. So, now what we're going to do is just go through and manually make sure all these are good. Alright, that side's good. Let's do this side here. Yep, that side's good. We'll do this side here. And then make sure when you're doing this not to actually bridge the solder joints. They're very close to these passive semiconductors here. Well, they're not semiconductors, passive components. And you don't want to knock one of those off the board either. It's very close. It's a very delicate procedure, and you have to make sure you're doing this correctly. And this kind of thing takes some skill. Alright. Really, we're just letting the flux do the work, because it'll allow the solder to draw up into the pins properly. Perfect. It's not 100% in alignment, but for what it is, it will work fine. And there, it's all mounted now. Now we just have to clean the board. And how we're going to do that, we're going to use our handy dandy flux cleaner and a Q-tip. That hit me in the face. I'm going to leave that blooper in there. Alright. Clean that. 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 Alright, perfect. All clean. Let's check the back side. Yep, back side needs clean too, because there are vias through here, and some of the flux will come through the via. And then we'll need more cleaner. Perfect. There. So now, another inspection. It's all good. That chip is now mounted in place. So for the check of sanity here, we're going to go ahead and do another ohms reading, because remember what it was before. It was like 62 point something ohms. So we're going to do another ohms reading between here and where we checked before, which was right here. 75 ohms. That's exactly what we want to see. So, new chip is installed, and the reading is exactly what it should be. Alright, so this board is done. We can now move this out of the way, and we can start working on the power supply. And that's going to be next. Now that we have the analog video input output card out of the way, the next thing we got to focus on is the power supply. And this power supply is basically an ATX power supply, but it's fairly proprietary because you have all these Molex plugs on them, and they kind of look like ATX plugs, but they're different. And this one is actually made by alpha power, and the APR 3510 is the part number, and it has a weather channel inventory tag number on it. And then the front of it is like we saw earlier. It's just the two tabs come in so you can pull it out, and then there's your pull-out handle. So really, these things, they're pretty reliable, but they are known, because these things run 24/7, they are known for the capacitors to actually dry out in these. They don't go bad like Plague Era caps do. And anybody that's familiar with the Plague Era knows exactly what I'm talking about. They don't do that on these. Typically, with these, they just, from so much heat and usage, they just wear out. Because with capacitors, especially in a power supply, you have what's called ripple current. Capacitors are rated for a certain amount of ripple current, and that's the amount of current that's actually flowing through the capacitor as it's being charged, discharged, charged, discharged. And that can wear it out by generating heat. And the reason why it generates heat is because of what's called the equivalent series resistance, or ESR. As the capacitors age, the ESR naturally rises. When it does, it, even under an AC load, it acts as more of a resistor. And it keeps doing that, accelerates, because when you add resistance, you get heat. You get more heat, it drives up the value of the resistance, which causes more heat, and then it spirals out of control, and then eventually the capacitor dries out and it goes back. So, okay, I gotta move that out of the way. I gotta move some stuff out of the way, but alright. The power supply right here. So, yeah, you'll see that in a second, but there's circuit boards in here that are all sandwiched in. So, and with the computer power supply, these are just standard off-the-shelf ATX power, but this form factor is proprietary. So it's not like you're going to be able to just say, oh, I'll just buy a new power supply. Well, sure, you could, because it's an ATX motherboard. You can just go buy another power supply, but it's not going to fit in that case. You're going to have to rig it in there. So, anyways, alright, so now we have that. We got a plug. So we're going to unplug this plug here, I think. Yeah, we'll get that in a minute. It's tight in there. And if you don't want to see this, then feel free to skip on through. But I'm probably not going to video the whole thing. I'm just going to video the disassembly and then kind of go through it here a little bit. It looks like this power supply has been apart before. Maybe. We'll see. Alpha power. Alright. Fingernails are already dirty. Hands are already black. That's the joy of working on this stuff. And there's that stupid super glue that always, or circuit board glue that always just, ugh. Alright, so the other thing we gotta do is we have to clip out these zip ties, because otherwise it's going to be hard to get the wires out. Then we're going to unplug the LED to the back here, and we're going to unplug the fan, which is plugged in down here. So the fan and all that's out of the way. And then we're just going to so gracefully remove the fan. And at this point, these fans run extremely loud, and this would be the point at which you would install like a Noctua fan or something to kind of replace this one. But that's okay, because this is mine and I don't really care a whole lot. But there, fan removed, extracted. Now it's out of the way. That'll make it easier to get this power supply apart. The other thing I need to do is I need a tool. Where are you? There you are. I think this is the right size tool, but you have these standoffs here and here that need to be removed. And I picked this up years ago. It's a Sonnet upgrade. Nice Phillips on one end and a tool to remove those standoffs on the other end. So I can just grab it and turn it ever so slightly with a lot of force. Yeah, that's not really... Yeah, that thing's tight. Make sure to crank those down. Okay, so that means I'm going to need a little bit more persuasion. Nope, that doesn't work either. That has no annealing on it, so let's see. Let's try another one. There it is. Let's try it again. This time we'll just crack them loose because these things have been tight. Ugh. Yeah, they were very, very, very tight. Now, I can get that in there and screw them. There. Good enough. That's out of the way. Now I can get these screws out of the way. There's one that's hidden back here. And then there's another one hidden over here. And now, with any luck at all, this one has a ground wire on it, so pay attention to that. Now, with any luck at all, this board should be free, and it is. So now comes the fun part. You got to get these Molex connectors out, and these use these one-way inserts, and they're such a pain to work with. So what I think I'm going to do with that, well, maybe see if I have a nut driver that will fit in there. This one might be. Also got this a long time ago. PowerBook nut driver. And that will fit in there. So what we're going to do with this is move that out of the way first. Get that up, get our little screwdriver here, and we're going to take this and we're going to work this inward, and while turning. Once you turn it, then you should be able to get a screwdriver or some flat tool in there and pull it out. Just like that. And then we're going to do the same thing on the other side. Again, you got to rotate it in the right direction as you stick the nut driver in there, and then get it to where you'll feel it kind of pop, and then you should be able to really pull that out. It's not ideal, but it will work. There might be a better way to do this, but this is how I do it. And there it is. Now loose. And there. I didn't ruin anything. Now it's all out of the way. So we're going to do the same thing with these two. Again, we're going to work it with, just work it like a screwdriver and then get it in there. And should be able to, in theory, get a flat blade screwdriver in here. Getting it to pop loose is the fun part. This one here is a lot thicker because there's all kinds of wires in the place. That one's out of the way. The same thing over here. Oh, felt that one pop. And there we go. That's loose. So we can pull this out of the way, which will help us in our endeavor to get the one next to it. Same thing. We're going to turn it with until it consumes it. That one's hard to get a tool in there. Yeah, that one's not like impossible. And this is just a 1/4 inch nut driver, nothing special. Oh, this one, oh nice. This one, they decided to, oh, that's wonderful. Why would you design something like that? Oh wait, I forgot. It's not meant to be serviced. But guess what? I'm servicing it anyway because I don't care. Yep, that's exactly what it was. We'll do the same thing with this one over here. Again, go with the grain. I say grain, but it's not a grain. You'll feel it where it just grabs. Boom. Done. And there's a bunch of different bits in here, but not important for this application. So gently, without throwing it all over the table like I'm doing right now, remove the main board. Oh, didn't expect that to happen, but it did. Okay, set that aside. We don't need this. This is the EMI filter network, so it can go off and out of the way. There's a piece of paper in there for some reason or another. And there we go. That is the power supply. And let's take a look at the caps, which I don't see any that have popped, but that doesn't matter. What happens is they get hot because they're kind of sandwiched in there a little bit. You can kind of see that. See that? They're just hiding out. So the problem when they hide out like this is it traps heat. When it traps heat, they boil to death, and these power supplies do not come on when they're cold. That's what happens to them. They'll be working perfectly fine, shut them down, let them cool down overnight or a few hours. They won't turn back on again until you heat these up. So that's what happens to these. And the only fix to that is you have to recap this power supply. So that's what we're going to do now. I've got the power supply out of the case, and at this point it's literally just changing caps, which we don't need to video all of that, but that's what we're going to do. So the next thing you're going to need is the proper tools for the trade, like this Heiko, what is it, the FR901, yeah, or no, 301, that's it. The Heiko FR301, you're going to need that because you absolutely have to have that tool. Well, it'd be a lot easier to have that tool, or unless you're a Chinese clone one, but you need the right tool for the job so you can get these modules out. And this is a multi-layer board, so that's a little difficult to do with solder braid. But you got to get these modules out here, and this one here, which kind of fits in that way. Then you also need to pull this MOSFET array out, which sits right here, and move it out of the way. That way you can actually get to the capacitors that are actually hiding in between here. There's one back in there, a couple over here, and then there's a module that goes on this side that has to be removed because you got to be able to get to all of those capacitors in there. So once you get it all out of the way and get it removed, you should be good to go. This should not present a problem anymore. So we should be good. We should be golden. The other thing you got to do is you got to get all this circuit glue off, like I did over here, because this stuff starts to turn like a dark brown, almost black, and when it does, it gets corrosive and conductive. So you can't leave it in there. You got to get it out of there, and I had to do that with these pair as well. So something to keep in mind is that circuit glue goes conductive, and you got to get it out of the way. All right, all the new capacitors are installed now. I kind of moved that one over and pushed this down because this is a terrible design. Why would you put a heat producing device next to a fluid filled component? Anyways, so those are replaced. All those are replaced. That one, all the ones in here have been changed out. They're all kind of hiding over there at this point, but so yeah, they were fun to get out with all that circuit glue in there. That circuit glue's got to come off, so I tried to scrape as much of it off as I possibly could. Now, this is probably the third variation of this power supply I've seen so far, and notice I've got components left over. It's because there's been different variations. For example, these have dual 2.2 microfarad at 50 volt caps, which I didn't have, but I had them in solid state versions, so I put those in there. Because I've seen another one that had a 10 microfarad, a 4.7, and a 22, which I have over here, but this board doesn't have that. And then I had another board that this was different, or maybe it was this one, I don't remember. Point of it is, I've seen like 3 different variations of this power supply so far, so just having a bill of materials stuck somewhere for this is not going to really help you much. So anyways, I just wanted to say that I'm going to go ahead and get all of this stuff soldered back together and get it put back together, which I'm not going to film because you saw the take apart, so we're just going to go ahead and put it all back together now. So with the power supply complete and out of the way, we need to start getting this thing put together. And from last video, we got the motherboard recapped and got all the new capacitors in there. So I got to get the screws all put back in the motherboard. We've got to get all of these addressed, put back in here the correct way. And yeah, that's pretty much it. We got to get the drive cage back in here, and we're gonna have a solution for that in a minute. So, but before we get there, get all this out of my way. Should be able to get it all put back together. Once we get it all put back together, I got to test that card that I repaired, and I'll probably just put it in there for now and not anchor anything down, because it's got to come back out because I got to put my stuff in there. But before I can put my stuff in there, I have to rebuild, or I have to put my Thunderstorm card back together. So yeah, it's gonna be fun. But yeah, so we got to get this all done and put together, and then we're gonna continue on from that point. All right, I got this bolted in here, and it's still loose up front. I don't have the face off yet. I have the motherboard all screwed in. Everything is ready to go. I just have to run these cables over here. But another thing I wanted to address before I get too far is this guy here. I was able to secure a new cage. It came from another IS-1 that I scrapped out. So I got a new cage, and I got the original sled, because if you remember, mine was missing. So I got the original sled, and I got the original hard drive that went to this. But if you're running different versions of the software, you need to be able to swap around hard drives. So what I'm going to do is I'm going to install this guy, which is an easy swap for. They're still out there. This is a SATA enclosure, but it has a Molex input. And that's important because the original drive caddy, same way. SATA, but it's also got SATA power and SATA, or regular Molex, but this machine uses standard. There's no SATA power in here, just a SATA cable. So sure, I can get a SATA adapter, that's not a problem, but this drive is already, or this bay is already set up to where I don't need that. So we're going to install that in there, and we're going to go ahead and put this drive cage into that. And I didn't have the screws for the drive cage either, but I got plenty of them back here from IS-1s that were scrapped out, so should be good to go. Alrighty then, I got the hot swap bay mounted in there, got the drive in place, got all the cables in. I just got to flip it around and get those cables in, and then get this mounted in place. So if we take a look here, we now have the hot swap bay installed. A little bit of a gap, but it's not that big of a deal. It'll tighten up, and then power supply screws have to go in there, and it should be good to go. The other thing we have to do, there's a couple more things we have to do, is we have to clean off all this crap, because this was sold in the 2016 fire sale, and I ended up buying it off of somebody else. But yeah, clean all that up, because I don't like that. That's triggering my OCD. The other problem is we're missing screws on the handle, so it's a little on the loosey-goosey side. But good news is I should have the screws in there somewhere that go into this, because I've already scrapped one of these machines out and built it inside of another case. Anyways, so I'm going to go ahead and start getting this thing buttoned up, and we will do a power on test before we start working on some more cosmetic stuff here. Alrighty, so now we got pretty much everything in here. Got the video card in there. It's only secured in there slightly. The Thunderstorm board is in there. Not my Thunderstorm board, but the one we were using in the first video. The Ethernet card is screwed down. The modem screwed down, even though there won't be a modem. But here's the card that we worked on earlier. And you can see where we reworked the chip. So what we're going to do now is actually insert that guy right into this PCI slot. Somehow, and it's kind of a tight fit. There. It's in there. Next thing we're going to do is put in our SATA cable. It goes, where do you go? Right here. And I don't want to do what I did last time, which was screw the pooch. I can't get it in there. Yeah, it's kind of a hard, there it is. It's a very hard spot. So, alright, that's in there. Next thing we're going to do is get the actual cables in place, like so. Be careful, line everything up. Alright, that card is now in place. So, alright, I suppose at this point, I think we're going to be ready. I took the face of it off. So everything's all in there now. We got the drive bay in there, all that's in there. So I think at this point, it's time to perform a power-up test and see what this guy does. Hopefully it works. Alright, looks like we're loaded for bear. We got this all put together somewhat. I've got a drive in the bay here, keyboard out, mouse. So now it's just a matter of connecting power and see if it comes on. Oh, I didn't like that sound. That was not a good sound. Oh, dang. Well. I'm going to say that power supply didn't survive. Yeah, and sometimes they do that. They will explode like that. Yeah, they will. Ooh. Oh, yeah, that stinks. Oh, yeah, that stinks. Okay, so the power supply did not survive. Alright, well, so much for that. And that's how it goes sometimes. Oh, I smell it too. It smells awesome. As in, it's screwed. Okay, well, either A, I did something wrong, which is entirely possible, or B, it was on the verge of failure anyways. So, okay. Yep, alright. That guy's done, so she's gone. So I suppose at this point, I need to just wire up a temporary power supply and at least see if this card works. Because I need to see if that card works, and if it fixes it. Well, that was definitely unfortunate. I mean, I have to figure out the determine cause of failure. It could even have been a mistake where I forgot to resolder something. It's hard to say. It happens. So we'll see how it failed later on. And then, but for now, I gotta get this card tested. So the best way to do that is to wire up a substituted power supply. And let's hope like hell that this one doesn't explode into a ball of flames. Alright, good. We're powered on. Alright, yeah, that's better. Now we're cooking with fire. And, well, everything that causes fire. Oh, we got hard drive activity. She's starting up. Let's see where we go. Do we have any activity from the thunderstorm board? No, we don't. That's not a good thing. Why is the thunderstorm board not working? Oh, I know why. Turn the power off. Turn it off this way. Let's push the card in all the way. Let's try that again. Oh, I'm having a heck of a time today. Well, there's no back slot cover on there, so it's just open to the air if you see that. So it's easy for that to get knocked out of position. So let's try this again. Hopefully that card comes up. There we go. That's better. All right, let's try this again. Of course, now it's got to scan the file system because, yeah. All right, now that we're getting into FreeBSD, see if we get video now. Got a click, and I got video in. Of course, if you remember, we had that last time. The big check is, do we get video out? No, we do not. Oh, dang. All right. Let's mess with this plug a little bit. You know, I wonder if that's a fake chip because it came from China, and you know how China is. Yeah, I mean, kind of striking out over here. See if the presentation at least runs. Should. Yeah, presentation runs. Okay, so yeah, all right, well, I'm gonna have to investigate that a little further. I'll be back in a jiffy. All right, so here's where we are at. I'll figure out what happened to that one in a minute. But, so, I want to take a different avenue, and I want to rule out that the chip that I put in the other card is a fake. And I had an itching suspicion that might be the case, so that's why when I ordered these used ones, I also ordered these new ones, because these are a lot more expensive than what those are. So instead of putting another one of those in there, I'm going to grab one of these new ones, and I want to put it on my card, because I know my card works, because this is my 540 card, so I know that one works. So I'm going to put this chip on this board, and if it works, I'm going to leave it alone. And I'm going to take the chip that I just pulled off of this board and put it on to that board. So that will eliminate that problem. Because if it still doesn't work, then I know we've probably got one of these logic gates or something that allows this chip to communicate across the bus. Has to be bad because there's really nothing else to it. The composite input goes straight through this relay, bypass relay, and into this chip. There's nothing in between except this filter network. And that filter network tested good on the other card. So, yeah, I'm running out of ideas. But let's try this first and see if that fixes it. And that's the problem with lightning damage. It's unpredictable what path it takes. So yeah, it could have fried this chip, but it could have fried a bunch of other ones too. However, we know the inputs work, which are responsible between these two and these two, as well as those and this circuit here, and that all works. So there's not much left on this board that could be a problem except one of these logic gates. We can roll out a lot of them because these two sections here on those four are grouped together with that one. Same thing over here, and these four are grouped together with that one, but then there's two additional ones over there that could be part of this, and there's one over here which is probably gating between these two, but I'm just guessing. So let's go ahead and get this chip mounted in place and see where we go with that. Alright, so I now have the new chip installed, and these chips are NXP branded, which they bought out Philips, I'm pretty sure, because there's the original. It's a Philips chip. But anyways, so there's a couple solder joints I have to touch up, but otherwise should be good. And I'm hoping this works because I used one of the brand new ones, and let's hope it works, because if it doesn't, then they're fakes. That's all there is to it. So that would be a shame, but we're going to try. All right, I left that chip right there, moved it around a little bit. The new chip and the original chip, they have the same package, same markings, the same spots, other than the NXP. So I have a good feeling about this. So I got my card in there now. The other one's still out here, but I have mine in there with the replacement chip on it. Like I said, this is my control. That one worked. So I just simply removed my chip and I put a brand new one on there. And then now we're going to go ahead and plug this guy in. Yeah, I know. I live dangerously. All right, let's see what we get. Not sure what's going on with the power supply yet, but we'll see that out. Got a beep. I'll put my finger down here. I want to feel the chip. It's actually getting warm. Yeah, that chip is getting warm. It's already a better sign than what I had before, because the other one stays ice cold. Put my hand back down there again and feel it some more. Yeah, it's getting warm. It's kind of lukewarm. It's not really hot. And they're supposed to get really warm. I got my finger on it. I want to see if anything changes. Now it's getting warm. It's really getting warm. All right, let's see. Do we have video? Hold on. Yes, we do. Perfect. Awesome. That means that chip is genuine. It's a good chip. Nice. And that relay click you heard is it going out of bypass mode, because if I go to the console in the background, now I'm at the login prompt and I control delete. You see it jump because it just rebooted. The machine just rebooted. So, all right, we're good now. Now I'm going to put this chip on the other card and see what we get. All right, so I got the other board now, the 0748 board. I pulled the chip that I put on there yesterday, or well, in your case, earlier in the video. I pulled that chip out, so it is now out of there, and I put mine that I know is good, the Philips one, because I left the new one in my card. So I put the Philips one in there, and then we're going to see if that works. I'm waiting for it all to cool down. Oh, I hope it works, because if not, then I know that chip is not going to be the problem. At least that may not be the only fault on this board. The other potential is it could be one of these logic ICs, because I'm not sure how this chip is gated to the Thunderstorm board as far as it communicating with it. And that gating could be a problem. Because if this chip doesn't get enabled or configured over the I2 bus, it's not going to work. So there's always that too. Alright, card is in place. Still a little bit warm, but not a big deal. So we are going to get this plugged in and hope like hell it works. Alright. She's warm, but it could be warm from reflowing solder it. Wait for it to start up. I'm going to leave it on that screen. It should click in and then bring it back over. At least I hope. Boom. Perfect. It worked. Holy crap, it worked. It was a fake chip. This chip is a fake. Thank you, China. That chip is a fake. Yes. Thank God it worked. That board is now alive. Lightning damaged. Success. Yes. Now it's a matter of figuring out what happened with that power supply, because she decided to explode. As you heard earlier, you heard the snap, snap, and then that was it. So I got it on camera, and I'm not editing it out either. It's all part of it. It's all how this stuff goes sometimes. So we're going to go ahead and take care of that. So now we got to come back to this and figure out what went wrong, because she went explodey bits. So I've got to take it apart and figure out if it's something that I did wrong, or if it was a genuine failure, because it's up in the air. It could be either or. So let's go ahead and get this apart and see what we can find out. Alright, so I got the thing apart, and the one thing I noticed right away is the fuse is absolutely nuked. So there's a hard short somewhere. I went ahead and measured that. I didn't see any shorts. I measured this, which is the input to this power supply. I didn't see any shorts. So I wanted to see, to make sure I actually didn't make a mistake anywhere on this board. And I don't see anything. Did I forget to do something? Did I short something out? What did I do? I don't see anything. Besides, if there was a short over here, the protection would kick in. That's so strange. So it's looking like a genuine failure at this point. So yeah, let me do some more testing and figure out what in the world happened here. Alright, so here's what I've determined. I removed the transistor pair here because this transistor is shorted and this one is testing okay, but I'm not going to trust it. They're IRFP 460As, which they may still be made. And I removed this board because this is the controller that runs this section. So this produces the switching frequency that runs these. And remember, I had to clean off the glue and I had to change caps on this, so I'm just making sure that I didn't cause any trouble with this board, and as far as I can tell, I don't think so. Well, maybe, but I don't think so. So I'm going through here, and the way this actually works, from what I can tell, is these transistors drive this transformer here. That transformer, and then this is this guy runs from these two transistors here, and I believe so. But this transformer actually drives these transistor pairs, which in turn runs the whole power supply. This transformer is independent and it's driven by this transistor here, which is controlled from the same control network. This one's okay. This one's okay. These two driver transistors are okay. It's only these two that shorted. Well, this one. So I did make a mistake when I removed this the first time around. I ripped out some of the the plating on the side of the wall, but it still shows a connection, so I don't think that caused my problem. I can't figure out something that I did that caused the problem, so I'm beginning to wonder if it was just it's time for these things to go, because sometimes it happens. Anybody that's worked on computers knows that sometimes when you plug a power supply in, they just spontaneously combust. Pop, pop, smoke, smoke, and then that's it. And that's what happened here. So there's two ways I can go about this. I can either find a power supply and restuff this one with a new board, and that seems like it's going to be a pain in the butt. Or I can rebuild this power supply, which I think I'm going to lean on that side. I'm going to rebuild the power supply. I checked the other diodes and stuff in the area. They're good. And I checked over here to make sure I didn't make a mistake, and they're all good. So whatever failed in this thing was not caused by me. So I'm going to go through and double check everything, and then I'm going to get a parts order together for this these transistors, and see if I can't get this controller IC, which is a ML4821. I've never seen that. It's made by Fairchild Semiconductor. It may or may not be around anymore. I'll have to see. But I got to get those parts ordered. So with that is going to conclude part 2 of our IntelliStar restoration series. The third part and final part should be coming up afterwards, because we got a few more things we have to do. But I think for now, this is a good amount of content for a second video. We got the lightning damaged card going, and we got some blooper footage too. So hey, it's going to make a good video. Anyways, I have a Discord server now, and you can follow that in the description below. There is an invite link if you want to join my Discord. Also, there is a cleaning thing I got to do with the face of the unit, as well as getting the Thunderstorm card put together and all that stuff. So that'll all be part 3. Anyways, thank you for watching. Feel free to leave a comment if you have one.